next class you will sing solo version. Everyone turn on or just the one who did not upload in the Padlet? If you have difficulty to turn on your webcam, as I mentioned yesterday, you need to just log in with your mobile phone and then turn on your webcam using your mobile phone. So I can see here only Yusuf Khalid, Said Abdullah, Amir Said, Darwish, Syahmi Izwan, Azhan, Zulaika that turn on the webcam. If you don't want, then I call your name, okay? Putri, open your webcam. Who else? Adam got here. I have turned on version. I will be back in a minute. I need to turn on the light. Yeah, maybe it's black out, but can you just turn on your microphone so I can hear instead I need to read instead of you need to write in the comment? Why all of you turn off your webcam? Please open your
no,
webcam.
We didn't turn off.
Open
it off. Yeah, open.
What?
That's
Let's
open.
see. Maybe my line. Wait. I close my WhatsApp. It's because it is me or it. Apa ni? Boleh tak? Can you just speak out? No need for me to read and open the chat room here. Is me or is there another Putri? Okay, I close the chat window so you cannot write any chat there. Is it you are here, Putri Shazana? Let me check. It's okay. I'm not going to taking too many time to find out. But this video is recorded. So whoever did not turn on your webcam now, next class, next week, you need to sing solo version, okay? So now for all the rest who already enable your webcam, you need to turn on your microphone and you need to sing. If I see that you did not sing, that you need to also sing alone, okay? Okay, can you see my screen now?
Yes.
Yes.
Okay. Got quite louder.
Kita menjulang.
Cuma kita menjelang.
Terbilang.
Yeah.
Wait. Arman
I'm trying.
is not turn on the microphone. Who else did not turn on microphone? Please turn on your
The
microphone.
English won't never do. It's Malay.
Yeah, it's Malay, but yeah,
You
having
can
fun.
read it, I think, like English.
Can't speak Malay.
You can read it like English, I guess.
Yeah.
Temen
Semalam
tulang bulan
Pinjam
yeah,
terbilang
tegelan
kemet
tulang
budaya
yeah,
tak
kemudian
usaha
budaya tak usah, yeah,
tak letaknya
budak letaknya, yeah,
PTN Batak
keilmuan,
pendek
yeah,
jawab
jadi awal
Jika bersama
bermatra
bersama
bersama
wadah
takwa
cita-cita
menara
menara cita
kami
Yeah.
anak kandung
kami anak kandung, yeah,
bernaung
kenal
bersama
bahasa kami
kamu
sahabat
kau
bahasa ilmu
Nemo
cara
sama
perjuangan
dan
takwa dan iman
iman
iman pengajaran pendidikan
dan pendidik
penulisan perundingan
pendidikan
kepada watak
kepada watan
disiplin kami
berdiri
dalam belajar
Semua berbudi
bermahal bahasa
PM
BM Sanjung dan Bangsa BM
Sanjungan
yeah.
Wow. So I think I'm not going to like get like educational student, but also maybe I can create more singer worldwide. So thank you so much. So let me ensure that I have approved for those who still not yet sing today. So don't worry, you have your versions of song, which is a single version. This is a group for fair for them. Although I can see that like Arshad did not understand Malay, I guess so. He's trying to.
Ma'am,
Yeah.
I have a question. Was they supposed to sing because they already filled up the palette?
You already.
I already, but I
You already-
sang along.
For this one is did not fill in the palette.
sorry.
Maybe it's like bonus for us to have someone already written in the Padlet to sing along. Okay, thank you so much, Amir Syed, Zulaika, Yusuf Khalid, Shazmi, Azhan, Darwish, Syed. I hear like Shazmi and Azhan voice much more clear maybe, and Yusuf Khalid also, right?
Yes.
The rest I cannot hear. But it's okay.
I sang. I tried.
But it's okay. After this, we have another singer to come to our class because I don't know what happened, but they did not turn on their webcam. So thank you. Can you turn off your microphone all? But all the students are required to open your webcam now, as mentioned yesterday. Because I'm going to start my class. Please enable your webcam, and whenever I like teach, like share a knowledge, maybe if let's say I stop and suddenly I check your webcam is not turned on, then I'm going to ask you a question. So everyone ready? Tanja Ting, Sair Ala, Lauzian, Zejunmar, Chinzen, Zing Chai, Sun Parng, Shefi Mahmud, enable and turn on your webcam. Amir Syed. Okay, so I start the class now. We're going to like having a session sharing. I don't want to talk with my laptop as mentioned. So let's have a fun class. Maybe you can interrupt me because it's quite boring to just hear one person talking without like anything interrupt or maybe stop us. So please make sure you just turn on your microphone if you have like, oh, this one I already learned. Maybe you can just share when you learn that thing and so on, just to have like communication between each other. Okay. I'm going to share my screen now. Okay, this is all about introduction on digital logic. Mostly our class today, personally, me myself, I think it's quite boring. It's quite bored because we need to learn something that more on like theory, and I guess the question also will be asked in part A section, which is multiple choice, like what is the term, what is the advantages, what is disadvantages. So it's quite like theory. So I love my type of person. I like to like having the technical things and like calculations. So the part that we're going to learn today quite bored, but you need to also learn. So the first thing that we're going to look is digital and analog. Okay, I found the lucky person now. Zenyuma, are you here? Zen, is it Zejunma? Are you here or not?
I'm here.
Okay, you did not turn on your webcam, so I'm going to ask you a question. Personally, based on your understanding, what is digital and what is analog?
I don't know this.
Again? Okay, I repeat my question. I repeat my question. Based your own understanding or maybe your background, you have learned on digital and analog. What do you think digital and what is analog?
Sorry, man. I don't know this.
Okay, can you enable your webcam?
Oh, today not. I use my friend's computer.
Okay, can you log in into your using your mobile phone? Okay, please log in into your mobile phones later on. For now, I'm going to start, and I'm going to check back your webcam. Okay. So first of all, today, what we're going to look is we're going to look into analog and digital. So anyone might have any point of view what is digital and what is analog. Maybe it is not supposed to be correct. What do you think analog and what do you think digital? Yusuf, what do you think?
I don't really have clue, but I'll guess like digital is based on numbers, maybe analog patterns or something.
Okay, thank you for your answer. Shazmi, what do you think analog? What do you think digital? Just
I think
mm,
generally for me, I think digital is anything to do with uh, uh, devices that appear in numbers. For me, that's my understanding about digital. While analog is, for me, it's anything that has to do with the clock, time, I guess.
okay, thank you, Shami and Yusuf. So now, first we need to look into what is digital and what is analog. And this kind of things is important for your part A because normally part A they're going to ask you a lot of definitions, a lot of differentiations. So for part A you need to understand the terms. So no need for you to memorize all the sentences over here like most natural quantity blah 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 blah. No need for you to memorize all the words, but you need to know the keywords. For analogs, it will be in terms of continuously, while for digital, it's going to be discontinuous, or we can call it as discrete. So on term of analog, you can see over here, this is like a example of waveform. You can see that it continues. There is no stop over here, just continues in time. And every single second, every single hour, you can see, let's say over here is 0.4. There will be a value or the data. Let's say over here 1.7. You also have the data that you can relate to. But in terms of digital, you can see that you can see that the value of your data for the temperature is only at the specific point, which is discrete and discontinue. You just take the sample of data at 0, at 1 p.m. a.m., at 2 a.m., at 3 a.m., and etc. So there is no correlation between each other, between from 1 to 2. So you don't know basically what is the temperature is between 1 and 2, 1 a.m. and 2 a.m. And sometimes it was like, okay, maybe you can taking the average. So this is the big point for you to differentiate between this analog and digital, which is continuous and discontinuous. Okay, that is one point. Another one is on analog system normally can handle higher power. Okay, the example is analog system being used in your house, in factory, in manufacturing, and so on, because they need to have power like at your home like 240 watt, right? I forgot already, but I think in this range. So if you are using digital system, you cannot support this higher in power. So normally digital is using a small battery compared to analog, and system can support like maybe your power bank, your laptop. So only a small power can handle digital system. So first over here you have the example of this signal, and from this one you can see you have the time, you have the pressure. Pressure is the equation for you to like checking the pressure, and then this one is temperature. No, this one is just example on analog system. Time, pressure, energy, it is all consumed for the analog system. And this is the example for digital signal. And later on you will see also there is several looks on digital wave. But as to see basically that it is not continuous and there is no correlation between each others, uh, this is how we represent. And digital system basically can process, store, and transmit data more efficiently because you transmit only like point by point. So easy for you to transmit rather than like continuously you send, so that sometimes it might be have interrupt and so on, right? So this is the differentiation between digital and also analog, and the terms definition, I guess so. So is there any, okay, this one is another definitions or differentiation between analog and also digital. Okay, basically analog, you can see over here, the value is can be vary. You can see over here. The value can be vary from 70, 75, 85 until infinity. And analog system combine a device. Okay, this one is later on. Okay, so it use a 10 decimal. While for binary, okay, don't confuse with this. This one is just for you to see the differentiation, the waveform. The waveform. But normally, the digital will only use base 2. So this base 2 thing, base 10, decimal, binary, hexadecimal, and so on, you already learn in your mathematics form 5, I guess, secondary school. So it's not very hard, but in this subject, we also will look into this numbering system also. Is it? Yeah. Okay, now you can see over here, base 2 normally only have 0 and 1. While base 10, we have 0 until 9, which is altogether is 10. Same goes to 2, you altogether have 2, 0 and 1. And it can be low and high. And for what I can say, okay, because we have several lecturers in this digital logic, you might also notice that sometimes maybe the lecturer prefer to like, okay, it is 0 and 1. But sometimes lecturer like having their like, okay, I pick this low and high. But sometimes there is also on and off. It's depend on the question. As long as you understand 0 is off, 0 is low. 1 is high, 1 is also can be called as on. This is normally refer if you have a question on like a switch or a light to turn on, turn off. So on is 1 and high, off is 0 and also low. Okay, this is the example as you already see previously. And this part you can see you have only 0, 1, 0, 1, 0, 1, high and low, and then on and off. Okay. And this is just like extra example for you. I don't think that it's going to be asked in your exam or test, but yeah, you need to know that there is a step for you from analog signal, you can convert it into digital signal and vice versa. So there is a converter. Later on, you will see what is the converter name. And on top of this, you can see there is step 1, step 2, step 3, step 4. But normally, we're not going to ask what is the step 2, what is after step digital analyze of signal, what is the next step. So this step, normally we didn't ask. So you need to know only like what is the converter, is it analog to digital or digital to analog, and so on. Okay, this is how basically the way for you to sample and convert from analog to digital. You can like read by yourself this example, and if you like buy the books, maybe there is extra example if you compare to the slide. Okay. Yasir Allah. Yasir Allah. Are you here or not? Yasir Allah. Okay, I just removed Yasir Allah from this class because he did not respond me. Shifildin Mahmud. Are you here?
I'm here. I'm here.
Okay,
Yes, yes.
what happened to your webcam?
My laptop doesn't have a webcam. I
Okay,
will try to get to buy one today.
okay, maybe you can try to log in into your smartphone. Okay, by the way, I just want to ask you, maybe you can like grouping this example. Which one is analog and which one is digital?
Uh, Smartphone is digital.
Okay,
TV, I think digital
which
too.
TV?
Bottom right, the one on the
Bo-
bottom. Yes.
Both of them is digital. Bottom
Yeah.
F.
F
Okay. Another one on the clock.
clock. analog or
For analog A or D?
I think A.
Analog is A. Okay. Thank you for your answer. Okay. Let's recheck whether he answer is correctly or not. Before that, okay. Uh, is it Bohari here or Darwish? Darwish. Do you think that the answer is correct?
Yes.
Okay,
Yes.
thank you. So the answer is correct. This is analog. This is analog, and this is also analog. And the digital one. Okay, this is digital. This is digital, and this is digital. Normally, if like you want to compare the old versions or traditional telephone is normally analog system, which is you need to like continuous press it. I think I already closed it, right? Why I heard something?
He raised his hand.
What?
Raised his hand.
Yeah, I did raise my hand.
Oh,
I have
okay.
a question.
No need for you to rest. Then you
He
can just
didn't want to interrupt you.
okay.
Yeah. How can I know the difference between them?
How can you differentiate between digital and
Know the difference.
I guess your voice is not too clear.
Said, how can I know the difference between if it's an analog or digital?
Okay, as we already like look into, you can see where is my okay. Normally for analog, the system is continuous. Okay, for this you can see every single there is a value, but for the digital it's like directly have the value in district, which is not continuous. You're not going to have like 0 0 0 0 point something that. And for the digital for the phone, this one is the digital form, which is the new version. But you can see for the traditional, if you want to call, you need to like pull from zero to move to the specific number, so it continues. It's not like you press 1, press 5, press 7. No, so you need to like continuously. And for television, I don't have clue how the system make, but nowadays if you have the old version of TV, but you can connect them to, I guess there is like box for the digital encoder. Still, you can use the digital waveform signal. So the system inside, I cannot know how basically it look like, but it is analog for television, the old version. But the latest one, all is digital. And last time I have quite similar with this television, but still I cannot use the digital signal from television. Malaysia is just moving towards digital.
Excuse me, doctor.
Okay, yes.
I think there is one of my classmates cannot join this class. He updated it in WhatsApp. He said he has problems with his Google Meet, if I'm not mistaken.
Oh, not because he cannot join. I guess he's the one that I kick.
Oh.
Yeah,
he showed that he has problem with his Google Meet. So I'm not so sure about that.
Okay. Then after kick, I guess you cannot enter. Okay. While waiting for Yasir to figure out, so don't do that again. Okay. Maybe you have also experienced how the inside system look like. I don't know about this television, but okay. Last time, I guess starting from last year or last 2 years, our television signal from our television signals are moving from analog to digital. So my televisions is look like this, but I don't know. It is basically analog. And if I want to use the digital signals, television signal, I need to use a converter. So the converter allowed me to watch the digital versions of channel. Isn't it channel? I guess so. So that is so how it's basically changed and the system inside for television I cannot mention, but basically at previous slide how you need to differentiate between analog and digitals is already clear, which is analog is continuous and for the digital is much more discrete and discontinuous. Okay. So this is about the example between analog and digital, and basically this is just like your knowledge, and mostly the question is not too hard, just more on theory for part A. And okay, over here we have a way we apply basically our digital system is on a computer, manufacturing system, and all of this listed. So this is the example of modem. I don't know whether you're aware about this or not, but if you have Uni5 or any kind of wireless internet connection in your house, you're going to have these kind of versions. Okay, when I first learned about this is when I did my master, because before this we don't have internet at home. We only have like streaming, which is wired using telephone wired at that time. And when I join and further my master, I need to configure the router. This one is normally called as hub. You will like learn maybe if you take data communication or maybe other subject, they like having several type. It called hub, switch, and also router. Sometimes it's nearly looks similar, but the function is slightly different and they are in the different layer. So this is just example for your knowledge, but of course it's not going to be asked in your digital logic subject. Okay, this is how digital and where it's applied in the sectors, and you can see this we apply in the manufacturing system. This is entertainment. This is on computer. Of course, you know about this whenever you want to buy laptop or computer. Last time we older version of human, which is me myself, we don't know basically this processor. We just buy a laptop, a computer to go to study. And now today, I guess when you want to buy, you always look into, okay, what type of processor? I want the faster processor, or maybe I want to like show off to my friend. I got this Core 7 maybe. So my processor is much higher than you, so you can compare with your friend. So that's why nowadays processor is not a new terms. I hope that all computer science also know what is processor. And then this one is applied in transportation. You can have this one is analog, you can see over here, and you can also have the digital one. So this is the digital one that apply in your transportation, and this is medical science, and lastly the telecommunication. Okay, in our life you will basically have pros and cons. So in digital, and same goes to us, I do believe that I have advantages, I also have my bad. So same goes to digital, it going to have advantages, later on you will see the disadvantages. So for the advantages, it is to design, is on storage, accuracy and precisions are easily to maintain, programmable, and etc. So how basically the question will be asked? Normally it is a multiple choice question. Normally you will be like having several okay, normally you will be like having several answer to pick, so you need to like memorize several answer for the advantages. As long as you understand the difference between analog, I guess you can easily answer. And this is disadvantages for digital and any kind of things in this world. There is also pros and cons. Same goes to digital, and you can see disadvantages because it's greater than bandwidth, sampling error while you converting from analog to digital. Might be there is an error. Compatibility with existing analog system. Okay, this one let's say like the one that I have last time, which is I have television, but when I want to use the digital channel, I cannot, I need to have the converter. So it's called as a compatibility. If I cannot, let's say my television's not compatible for with this converter, so I cannot look and watch the digital channel maybe. And throughout, it is very short product lifetime. Although you said my laptop can like having 5 years already, but still the performance will like dropping a lot. And if you buy mobile phone or maybe televisions, they will be give you a warranty maybe 1 year 2 year, but suddenly after 2 years exactly, then like we have a broken something at our phone or maybe televisions. Compared to the old versions, compared to the old version of televisions, compared to the old versions of phones and on phones, they have like longer long versions of life. So that is the comparisons and disadvantages. Okay, you can also have analog and digital system mixed together in one system. Uh, the example is here. You can see here. Where? Is it my meeting? Wait, I want to close this. Okay. So you can see over here, you have the example when you have player, you are using digital this. This is all digital this, and you put it into your player, and it will convert it into analog signal which is the music, voice, and etc. So this is analog. That's why, as I mentioned previously, you're going to have a converter, which is ADC or DAC, which is analog to digital, or digital to analog. Analog digital converter, digital analog converter. So either ones. If let's say you have the digital, then your output will be analogs. It called as digital to analog converter. While you have the analogs ways, or maybe a form of ways for analog, and you want to convert it and to get the to get the digital, you need the analog digital converter. So this is how it's look like. And you can see over here, basically in your CD, you might also search in Google CD-ROM. Basically, when you have the CD, you're going to store your data in terms of I forgot how the structure, but okay, I just like draft it. So it's going to be like 0, 1, 0, 1. So you have a lot of portions, and all over here is 0, 1, 0, 1, 0, 1 data. Although it look like a circle, maybe it's like more to analog, it's continuously, but inside of this, you're going to separate it into several segment. I teach this COA subject, but I forgot already how to draw it. But there is a several segment, and each segment over here, you're going to have 0, 1, 0, 1, 0, 1 value. So this is basically how it's look like inside your storage in CD driver, which is digital. That's why it's form of 0101 digital data. And then you're going to go to the converter, and you're going to get your output in terms of analog. So this is just amplifier to like if you have a low volume, so you like want to have the higher volume, so you're going to use the amplifier to use the speaker, right? So this is example for your knowledge, maybe how you're going to convert and to make a difference. Okay, there is another things which is hybrid. I heard about this term frequently, but honestly, I don't know what is hybrid. Throughout maybe several years study, then like okay, okay, I want to know basically what is hybrid. Maybe I said that okay, hybrid. Like currently there is a lot of hybrid car. I was like thinking, oh, hybrid is not using oil, not using a petrol. It use electricity or battery. So maybe it is a powerful of car. So I heard a hybrid like that. But hybrid is whenever you have two or more system or different, I can call it as a system together in one platform. So you can see hybrid system, you have the combinations of analog and digital. So you have two. Then when you combine, it called as hybrid. Same to the hybrid car, you can use a petrol, you can use the power battery. I also don't know because I don't own and I don't interested to buy hybrid car. So that is the term of hybrid. Maybe you can also share your knowledge about the car, which is I don't know, and maybe you can share with us also. Just interrupt me whenever you think that is interested for you and important for you to share with us. Okay. Okay, you can see over here the audio CD is typically hybrid, which is have analog and digital system. This is how basically you convert from previous slide. Analog sound is converted into huh voltage using a microphone. Okay, this is convert to the voltage, and this is how step by step for you to convert. Okay, this is the picture similar to the previous one. So just for you to know and get knowledge about analog and digital. And only these two type you need to know, ADC and DAC. So there is only two converter. You can like having read on this. Maybe in a question it can be asked what is the function of ADC and what is the function of DAC and where you're going to apply. Maybe you like need to pick which is the correct picture for ADC. Maybe over here I just like draw digital and then this one is analog, but it is totally wrong, so this is not the correct answer, so maybe you need to find the correct one. So that is about analog and digital. Is there any question related to digital and analog before we can move to the next?
No, doctor, all clear.
Okay, thank you. Okay, now we're going to look into our next, which is digit logic level and also digital waveform. And towards next slide, I guess we rarely see analog anymore because as mentioned, this is a digital logic subject, so we're going to focus on digital waveform, digit, and logic. Okay, in this slide, you're going to see binary, digit, and logic level. So this is example from here. But on top of it, you can see in between there is no value. You have only high, you have only low, and the low is 0 and the high is 1. You will not having 0.5. So this is on digital. And normally high will be 1 and low will be a 0. So depend on how the waveform look like. You can might have like this kind of waveform as long as it's low and high, low and high. So a lot of way how you represent, but in this course normally we're going to apply the square waveform because it's quite easy for us and for you to understand and look into the waveform. And it is also not too hard because we have only 0 and 1. As long as another one is high, it's 1. Sometimes maybe, yeah, I cannot draw like carefully, but maybe I draw like this. Then you just notice this is the 1 actually. This is also 1 because it's high. There is no in between. Of course, in test, in final exam, we're not going to give you like this, but theoretically for digital, you're going to have only 0101 value. Okay, this one is okay. The most important is at point 2. You going to bring it until the rest of this topic. Over here you can see you have this one is okay because you have low and high. We already repeating it several times, but this one is new for you. A positive going pulse. pulse can be a clock. It can be also like a signal. It can be also a wave. As long as it called as positive, it's going to go from low to high. Let's say I have this kind of waveform. Okay, so I draw it's quite big because it's easy for you to see it. If you have next you're going to see like a clock and so on. Okay, so if you have positive, it's going to be from low to high. This is low.
It's 12 hours.
This is high. This is low. This is high. From low to high is going to be positive. Where is the positive side? This is your positive side, and normally where we put it, we're going to put an arrow like this arrow. Okay, you're going to see over here. Sometimes we didn't like mentions this is positive waveform, or maybe this is not a positive clock. So you need to know, as long as there is a arrow here, means that it is a positive clock. And if you have from high to low, from high to low, and you're going to have like this, it will be negative pulse, negative clock. Okay, negative. This one is positive and this one is negative. There is no just this thing. You cannot draw from 0 to high like this, because our wave basically we move from left to right. So whatever are moving, we didn't move backward. So that's why it will like goes like this. Then your negative error must be at the negative side. Negative side means from high to low. This is negative side. From high to low, you need to draw here. Okay, this is negative side, and your positive side will be here, which is from 0 to high, and the error will be like this. Okay, because this point why is important, because normally in questions sometimes it's not like mention this is positive clock, or maybe this is a positive pulse, but you need to understand by yourself how if let's say like this it is positive, then you will apply some kind of method if it is positive. If it is like this, so it is negative, so you need to apply different method rather than a positive. You will learn later on, but you need to straighten and understand from basic. So next is digital waveform are made up of a series of pulse. What is the meaning of digital wave are made of series of pulse is the one you have here. If you have this only one like this is not a waveform. This is just pulse, only one time. So if you have a waveform, you're going to have several series of pulse. This is one pulse, second pulse, third pulse, and several others continuously like this. This is a digital waveform. Okay, now you have another terms that you need to remember, which is on positive logic, which is active high, and negative logic is active low. Sometimes you're not going to be mentioned that is a positive logic or positive pulse. You were given only active high and active low. SM goes to like this one, 0 and 1, high and low, off and on. Same goes to this. So you will be have several way to like call it. There is a call versions of this. And this is how positive pulse look like, rising or leading edge. You can see low to high. And this one is falling or trailing edge. So this is positive or active high. This is the active low. And please take note on this differentiation. For active high, high will be 1. But for active low, high will be 0. Although I already mentioned it's here, you will apply this. I just next subtopic or next topic. So from basic, from beginning, although you will like repeating it again, we will mention again that for active low, high will be 0, low will be 1, but it's better for you to stick it and put it into your mind, so then easy for you to apply it later on in next topic. Okay, so for active low or positive, high will be 1 and low will be 0, while the active low is vice versa. And on top of like mentioning it in question, in sentences, sometimes we lazy to write, but on top of it, we just draw. We just draw a symbol to represent whether it is active high or positive, or active low or negative pulse with these representations. When you have the bubble over here, it is active low, but when you have nothing connected directly to your system or to your gate, it is active high. Okay, so it's easy for you like to memorize. Sometimes we don't want to inform you directly, so instead of that, we just draw it and you will notice whether it is active high or active low. Okay, until here, is there any question? So everyone understand?
Yes, doctor.
Okay, easy for you, right?
Doctor,
Okay.
if the bubble is next to the box.
Next here.
Yes, here.
Okay. Later on, you're going to learn on gates. You're going to learn about gates. There will be like this. We also will have like this. So this one, normally if you have bubble, we call it as negative or not. But this one, we will apply it into gates. And when you want to, you have, let's say you have 10 gates. You have 10 combinations of your gates. And to simplify, you're going to apply this bubble thing later on. You will apply it in front. But this is not representing of active high, active low, positive pulse, or positive negative pulse. Okay, the part for active and positive is at the left, but for the right side is normally for a knot. After this, you're going to learn knot get. It's half the bubble. You will learn get knot, get O, XO, and so on. So this one have a bubble, and whenever you have like several combinations of gates, you're going to simplify it, and there is a method for you to use these bubble things, but you will put it on your right. And this is not active high, this is not active low, this is not positive high, or this is not positive low representation on the right side. The one that represent the positive or active is at the left. Is it okay?
Yes, clear.
Okay.
Can I ask a question?
Yeah, sure.
Can the waveform start with a low active low?
Can what? Can we start?
The waveform
Oh
can it
yeah,
start with active low?
yes,
Oh,
like
it can
this.
start like that.
Yes, we can start with the active low. We can start from the negative pulse also. So it is depend on the question where the question start, whether it start from negative pulse or positive pulse. Okay. So another question. If not, let's proceed on two type of waveform. A square form. As mentioned, we're going to like apply a square form in our subject. So here there is two type, which is periodic and non-periodic, or we can call it aperiodic. And for the periodic, normally it's going to have periodic, periodic. So it's combination of like period and time maybe, but periodic only got time. And time we call is period we call, and we apply it in term of capital T. Okay, again let me draw the waveform. Normally we will, okay, okay, maybe we have this kind of waveform, and where is our period? Period is between like this, or maybe you can also start from here to here, as long as it is one cycle. Depend on the question. Normally it will be like starting from 0. If this is your 0 or 0 second, or normally it will start with like small t as t0, and then this one will be small t1, and this is your capital T1. Next is your capital T2, and the next T small is over here. So this is how basically your waveform looks like. And there will be a period and frequency. I do believe that you already learned about frequency, how to calculate frequency in your physics subject at your secondary school. So no need for like me to focus more. Frequency or the units is hertz, and the equation is frequency equal to 1 over t. T is your time or your period. Okay, next, our non-periodic or aperiodic, you can see that there is no repetition. Like this one, your waveform will be look like, but sometimes you can also have like this. As long as you can see this part is similar to this and it is continuously repeating, so it is a periodic. So this is one cycle, and this is another second cycle, and continuously, so it's periodic. But non-periodic, there is no repeating sequence, and you're not going to have a time for this non-periodic. Okay, this is example of several wave: sine wave, square, triangle, sawtooth. So this is normally you can see on your oscilloscope and etc. But in terms of this subject, normally will be pick square. So, and this one is example as a aperiodic signal or non-aperiodic. Now we have, I guess, a first equation. I forgot already. This is first equation that you need to memorize. This equation, basically, as I mentioned, you already learned in secondary school. Frequency equal to 1 over T, capital T. T is period. F is your frequency in hertz. T is in second. So you can see over here frequency or F, small f, and the units is hertz. And periodic, you can see over here a big T, capital T, and T, it is on a second. Okay, now over here, this is several example. Every example in the notes under the slide, in slide, and maybe if you already buy later on the books, please make sure you do all the example and exercise, because normally we going to ask question and we take from example and exercise. We will like changing the value, and maybe if let's say this one over here is F, maybe we change it into T, just vice versa. So please make sure you do all the example, play around with the value. Maybe you can do it with your friend. Maybe you like, okay, let me give you the value, and then after this you give me the value, and then I try to do it. So it's very good if you have friend, then you can like doing it together and change the value to like strengthen your skill, and also for you to memorize the equation. And this is how the oscilloscope look like for a square waveform and sinus waveform. And yeah, we go some about mathematics, and it is on conversion units. Normally in question we have several, although it is like digital logic, you're going to apply and play around with gates and circuit, right? Why we need to have mathematical things over here? Throughout, there is also several calculations that you need to do in this digital logic subject. That's why you need to memorize all these units, because we're not going to give you this value. On top of it, we just give you like 10K or maybe 1 gig. So you need to know what is basically 1 gig. And so if you have past year test from your senior, you might see there is a question just for conversion. Please find what is 10 kilo. 10 kilo, and then you were given with A, B, C. You have a possibility to have like 10 micro, and then maybe B is 100 milli, and then C you're going to have, let's say, 10 or maybe 0.1 mega, and so on. So you need to find where is the correct answer. So you need to know how to do a conversion. So let me like bring you go back to your secondary school, how basically you can get convert. Okay, now we have the example we were given with frequency as 100 kilo. So 100 kilo, I know that it is 100 times with 10 to the power of 3. Correct me if I'm wrong. I also forgot because I'm old already. So this is 1000 and this is represent as 10 to the power of 3. And over here, is it correct? Yeah. 10 to the power of 3. And from here, you can see that you can also convert it to be like 1 times 2, 10 to the power of 5. So either way, how you play around with the mathematical term. And you need to find the t. So what you need to do is 1 over f, which is you have 10 to the power of 5. You will get 0.1 times 10 to the power of minus 5. I guess so. So play around with this. And when you want to convert, you're going to like move your fraction over here. So this is the one that I want you to look into. If let's say you have, where is the equation? Okay, this is example. If let's say you are having this kind of S is microsecond, 10 millisecond equal to 10 to the power of minus 3. This is millisecond. So millisecond, you're going to move your fraction to the left. So you're going to move 1, 2, 3. Because your fractions or your dot is over here, and you will bring to your left 3 times, then you will get your answer to be 0.01 millisecond. And if you want to convert to hex frequency, then you're going to like have 1 over this value. I just want to show you this part. And if let's say you have this example, later on we go back. If you have this example, let's say you have 1000 kilo, means times to the 10 to the power of 3, you will move to your right. Rather than previously for milli, you move to the negative because it is negative, right? If it is positive, and normally positive, we're not going to draw it here. If positive, you move 3 times. 1, 2, 3. 1, 2, 3. So you have 1 million, I think so. You have 1 million, and then to get the t, 1 over 1 million. So this is how you do. So go back to the previous. You can see this example. You have 100 kilo. How you going to convert it? You have this one in this example is try to help you on conversions. You can see over here, although you have kilo, and this one you're going to apply 1 over f, which is 1 over 10 to the power of 3. You're going to get this kind of term, 10 to the power of 3. 100 times to 10 to the power of 3, then you will get this value. Later on, you will get this one. This is the one that you convert. You have 10 to the power of 3 minus 3, And over here you have this part, and you're going to play around with this value, but because of you time with 10 to the power of k, which is kilo, you're going to have plus over here, so you will get 0.1 millisecond from this part. I guess in this question it do this first and then this one. If you have 1 over 100, you're going to have 1, 2, 2. You will get 0.01, this part, and then you have another one is 10 to the power of 3. So please try to do it for the example and then memorize all the units. And over here, there is a several example and I give you the answer. You can try to screenshot because in your notes, there is no answer. You can see over here, this is your T, capital T, which is your period. And then you need to find your answer for your frequency. Oops. So you just need to convert first and then you do the 1 over your period. Then you will get your frequency. Same to the next. This one is a positive units. You can also have this example. Then you can try convert it. Please do several value, not only one in front. Maybe you can play around with 2, 3, 3,000, 200 and etc. So play around with numbers and you can get the period over here. So any question with the mathematical terms?
So
Okay.
far, okay.
So okay. Maybe you need to apply first, try to do the equation, then you can see. So next is on the pulse definition. So this is just example, although you are not like looking to the analog signal waveform, but where is amplitude? Where is the baseline? Where is the rise time? Where is the pulse width, fall time, and etc. So this is just example so you can see it clearly. But basically there is not much that you need to see. The most important like amplitude, pulse width, your rise time or fall time, and maybe your period, because you need to apply it in terms of equation later on. Okay, this is the example and this is much more easy for you to look like because this is more on digital. So you can see over here, where is your amplitude? So this is your amplitude. Of course, you're going to have only 0 and 1 for digital. And where is your pulse width? This is your pulse width. You can see over here. And where is your duty cycle? So your duty cycle not mentions and drawing any from your signal, but you need to calculate because your duty cycle is basically equal to ratio of TW. What is your TW? Is your pulse width, and 2T means that duty cycle equal to T, small t W over big capital letter T, which is your period. Where is your period? This is your period. As long as you know your period and you know the pulse width, you can get your duty cycle. So let's take a look example. Okay, in this duty cycle, you can see duty cycle in the system of active state. You can see active state means that it is positive and defined as duty cycle equal to TW per T, and this is a per 100, which is 100%. So over here we like putting percentage. So this the unit for duty cycle, which is percent. And there is an example which is a periodic digital wave has pulse width. It's already give you over here 1 millisecond and period time is 10 millisecond. So you have this part as 10 millisecond. You just need to calculate the duty cycle. How you need to do is d equal to 1 milli over 10 milli percent. 10 millisecond. So you will like having the value. How you going to justify? You can going to see 1 over 10 times with 100, and then you have a percentage. Then after you do it, you're going to get 10%. So this is your duty cycle. Sometime in the mathematical, you're going to play around with the equation. Maybe you were given with duty cycle. You need to find out the the pulse width. Maybe you were given with duty cycle. You need to find the period. So either ones, as long as you know the equation, is easy for you to answer. So there is several example and exercise. 1.3, 1.4. Okay, under 1.3, you can see over here. You were given the period, which is 100 millisecond. In the first place, you're not going to give like any signal. You are the one that need to like draw it by yourself. Okay, where is this part? This is like over here. Okay, this is 1,000 millisecond, 1,000 millisecond. And what is basically on state? What is off state? Then this is the term that you need to know. On state is equal also to your pulse width. This is the on state, or in a normal term that you learned previously, it is a pulse width. And this question they don't want to give you a hint on the pulse width, but instead they give you a hint on state. So on, this is on and this is off. So you have the on and off state, and the duty cycle is 25%. It's already give you, okay, this is 25% for duty cycle, and maybe you need to determine this on state, which is pulse width, equal to your on state or pulse width, TW. So you have these two options, similar things, and you're going to divide it into 1,000 millisecond times with 100%. So this one over here, and this is will be bring upside, and your T will be 1 millisecond, 1, 2, 3, 25, it shows the milli over here. So over here you have 25. Maybe I will just cross here. So I have 200 milli and I bring it up millisecond. Maybe if you cannot see mine, you go back and try to bring it up here slowly, and then it's going to be multiple, and this 100% will be off down divide, so it will be divide with 100, and percent over here will like cross each other, and at the end you will get your TW or on state over here 250 millisecond. And because the question asks also offset, so what you need to do, you know this one and you know this one, you just need to minus and deduct this part, you will get the offset. So your offset 1000 minus 250 millisecond, you will get 750 millisecond for your offset. Okay, there is another example, quite similar. So it is easy for you, try to do it. And again, maybe you can play around with the value. Also, maybe you can change, maybe it give you TW instead of time period. That easy for you later on to answer. There is another example, but it's slightly different. You can see that, oh, this question having short in sentences, but this question have longer in sentences and representation, but basically it's similar. It gives you the T cycle, it gives you the period. You just need to calculate the pulse width. Oh, last time in the last or previous question, they asked me to calculate on state and off state, but in this question, it can be also directly pulse width. So that's why I mentioned to you, as long as you know pulse width is a on state, then it's okay. It can ask you in terms of different term. And next, you need to find the off state. So basically, your step is similar. So any question? Easy, right? So if there is no question, yeah.
Doctor, the calculate for the on state is same with calculate due with the duty cycle.
The calculation of on state.
Is it same with the calculation of duty cycle?
On state is basically pulse width. So the equation will be similar. You're going to use the similar equation like this, but on state over here is also similar to your pulse width. Am I answering your question?
Yes.
Yeah. So pulse width and on state is similar things. Only as I mentioned, they just want to make you confused. As long as you understand, you can see over here, this is on, or this is on, or high, or it can be called as 1. So if it said on state, means that this is the one, and you know this on state is also a pulse width. So similar, you just apply the same equation. Next question, please. Anyone?
Doctor, to get the off state, we just minus the on state from the period of time, like the time period.
Yeah, because you have like this, right? Okay.
Yeah.
Okay, you have this is the period, and if you have the on state or the pulse width over here, you're going to get the value of your off state. So you just need to minus period minus with your value here, and you will get this part, right?
Yeah.
So only
Okay,
that.
thank you.
Okay. So any other question?
Doctor,
Hmm?
can you go back to the before? 1.3.
Okay.
Can it be the off state is 250 and the on state is 750?
Yes, if your waveform like this also can be yeah, it's ugly. Maybe your waveform is look like this one. Okay. Let's say
Oh,
this is your
the
this one
waveform
is
is given.
no, the waveform as I mentioned is not given, but this already give you the value here and here. You are the one that like to figure out how the waveform look like, because you will like get the value. Let's say over here, this is your period, right? So this is your period is already give like maybe 10, and then when you calculate, you're going to get on state value from this equation, right? You get, let's say, 7. So of course your period offset of state will be 3. So it's depend on the value given. If let's say your duty cycle maybe 25%, I do believe that it's going to be look like this. This one is maybe 25% only. That's why it's small for your on state. Basically, if logically you can see the ratio is how many percent your onset is. You can see it is 25%, it is 25. If and when this one is 27, 75, all together will be 100%. If let's say you have 50%, I do believe that it will be look like this, similar. This and this will be have like 5 millisecond, 5 millisecond, and this all is 10. If 50%, if let's say 70%, maybe it's look like this. This one will be 75. This one will be 25, and this will be like 100, 1,000 maybe. You calculate by yourself, but this is the correlation between each other. Can you get it?
Yes.
Okay, so the
Thank you.
waveform is not given at the first place. You are the one like creating it by yourself and calculating. No need for you sometime, because they didn't ask you to draw. They just want you to show the work. So this is the solution. So only you like, maybe it's easy for you if you draw and then you can see, oh, this is how this look like. You can see over here, because it is 50%, that's why it's like similar square. And over here you can see 45. So your duty cycle, your positive or on state must be smaller rather than your offsets. This one is 60, this one is 40. If let's say all together is 100, but because it is 500 millisecond, you need to figure out what is this using this equation. Okay, any other question? So if there is no question, let we move to the next, which is timing diagram. So in timing diagram, the very first thing that you know, it is represent with having 2 or more. So you can see over here, let's say you only have A over here, and this not going to be mentioned as timing diagram, but instead is like, okay, the waveform for A input. But when you have two or more, it shows that, or combinations of these, oh, this is timing diagram. So the clock over here might be also putting below part. It depends where you're going to put. And because I already teach a long time, I want someone to answer my question. Shazmi is one. Shazmi is one. Can you answer my question? Are you here or not? Shazmi is one. If you are not here, I'm going to remove you. Okay, I already removed Shazmi's one. Yang nampak kepala je dari tadi Blackpink ni. Muhammad Adam. Is it Adam? Cannot see your full name.
Yes, doctor.
Okay. I'm going to share my screen. It's okay if you did not answer it correctly, okay? I just want you to like participate in our class. Okay. May I know what is the value of A, B, C, and wait. May I know the value of A, B, and C and C2?
3. For A is 1, B is 1, and C is 0.
Laju. Tepuk tangan semua. I got class this morning. I asked similar question. The student informed me A is like 2, B is 4, C is I forgot already, but some kind of that. So thank you, Muhammad Adam.
Okay.
Okay. From this, you can see this is a timing diagram, the example of timing diagram, and you're going to have a clock. You can see sometimes clock can be upside down, and this one can be input. It's depend on the equation. Sometimes they can say, okay, this one is the output, the rest is input. But throughout, you need to understand how you need to like read the timing diagram. So I mentioned, maybe you already know, previously I already informed you, this one is T1, is your period 1 for your cycle 1. This is your cycle 2, T2, and so on. I'm too lazy to write. And this one, starting from here, normally you will not calculate this part, and this start will be T0. And then next will be small t1 and so on. But this, like what I can call this unit or representation, sometimes maybe they use different, but it's okay as long as you know how to read the timing diagram. The question will ask you whether it is T or whatever, right? So over here, my question to Adam is T3. So this is my T3. So supposedly my answer is here. So you can see under T3, my value of A is 1, 1, 0. So this is my answer for my ABC. And okay, so you can see over here also, you were not given the value. Instead, of course, if you want to draw after this, from this timing diagram, you can also need to be like convert it. Okay, this one is basically similar example. At the T3, you can see over here, basically it's all cover here. Maybe the arrow should be like this. So you're going to see what is the answer. And from this timing diagram, sometimes you need to convert to this table. And what we call our table in our digital logic subject, we call it as true table. There is several truth table. Later on you will learn how to draw it. So this is just example for a truth table that you might represent from this timing diagram. You have the input for A, B, you have the output for C, and then you have the clock. So you just like filling back whatever value you get from this example. Okay. So I guess it's not too hard, but later on you will like, truth table, because it might also confuse you, because the output over here is also always the answer from your understanding. Let's say you have the gate NOT, gate AND, and combination of all gates. So it will be depend on your understanding. If your output is wrong, then your signal will be wrong. Your truth table over here also will be wrong.
Doctor,
Yeah.
Shazmi wants to join back the meeting. He was having connection problem when you call him. So
Okay, he just can he just can try to log in, because just now Yasir also can log in back.
okay.
Maybe it takes time. Okay, now you can see over here, this is our example of timing diagram, and you can try to change. Okay, you play with your friend. Okay, aku draw like this, and then aku bagi kau macam ni, macam tu lah. So you will play around with your friend, you give your timing diagram, you pass to your friend, and then you ask your friend to pass you timing diagram, and maybe you can like convert it into truth table. So please try to do exercise in the beginning of weeks. You have a lot of time, so before wait for me to like give your example, maybe you can like proceed to several others, dates and so on with your friend, because after you going through like week 4 above, you're going to have like too many tests, too many assignment, too many, yeah, a lot of work you need to be done. Okay, and this is the last slide for today on the data transfer. Data can be transmitted by either serial transfer or parallel transfer. So there is if you like to play around with electronic thing, you have like torchlight, or maybe you have like control car remote and so on, you will see how your battery look like. Sometimes your battery, you need to join them together like this. So you need to know why it's look like this. But sometimes you can also see the battery will be look like this in the compact battery things. And then why there is something like this and there is something like this? Normally like torchlight will be having the circuit like this for your battery and so on. So this is all the type for serial and also parallel. Same goes to your data transfer. Maybe on this part you can see if you have serial, you're going to have serial like continuously sending in one parallel time. But when you have a parallel data, you're going to send bit by bit, one, 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 one. So this is look like. So same goes to your battery. You need to find out whether it is serial or parallel, and the data is also similar when you want to send the data throughout from computer to modem. There is a type of sending data, but it is not critical for digital logic subject because normally we will like play around with logic. Okay, so any question? We will continue next class with our introduction to logic operation, and it will be more fun looking at pictures of gates.
Doctor, in the truth table,
Yeah.
in like number 3 and 7, why do we have the same inputs but a different output? Like number 3
Why?
and 7, clock number 3 and 7, we have the same inputs but a different output.
Okay.
Why is that the case?
Okay, this one is just example. That is the first thing that you need to know. Okay, and the output next time after you like play around with gates, it will depend on your input. Then if let's say you have like similar input should be, your output also will be similar. Okay, but this is just
Okay.
example, and I don't know why they give the example like this.
Okay.
But your output next time will be depend on the combination of your gates or maybe on the single gates. So you will learn on, if let's say 1010, what is your output? If 00, what is your output, and so on. Okay, and
Okay. Thank you.
over here, where is it? I guess there is a several example that I give you. The value is wrong. I guess this part. So maybe if you like watch back this video, if you notice, I just wrongly fill in the value, and then if you screenshot, don't like confuse why it is 0 instead of this is 1. Okay.
Okay. Are these binary additions?
Yeah,
Like
this is
the int?
Yeah, this is
Uh,
all binary
okay.
because binary only have 1 and 0. I think after this, there is a part that subtopic you need to learn on number system, right?
Yeah.
Yeah, that one. If you don't like mathematics, it will be like quite hard because it's quite boring to play around with numbers.
Okay.
Okay, any other question?
Excuse me, miss.
Yes.
You called my name in the beginning of the class, but I didn't respond because I don't know why my microphone didn't work.
Yeah, you already WhatsApp in the group, right? Or maybe, yeah. Personally, I forgot
Yes, I
already.
said.
Okay, I noted about that. Okay, but it's okay. Next time, we will improve time to time. I just don't want to like teach, but you don't have response, and it's going to affect you also.
That just happened because this is my first time using Google Meeting. So
Okay, why I pick Google Meet? There is several platform. We can have WebEx. We can have Zoom. What else? But throughout, we find out that Google is spend lower than bandwidth rather than WebEx is much higher, and there is other several things that's why I go for Google. Okay. Any other question?
Yeah, other question.
No other question. So if there is,
I
yeah.
want to ask, please,
Okay, Ken.
about the slides and the recording. How can we find it?
Okay, normally what I did is after each class, because this class is recording, after finish I will download the recording versions, and normally I will put it into the e-learning, so you can like always find back whatever I recorded. And sometime I will like give extra examples, so I will record also and I will put into the e-learning, so you need to check your e-learning frequently. Okay.
All right, thank you.
Okay. So if there is no more question, thank you for your participant, and I hope that we can meet again next week. Till then, please stay. It's 13 hours. Please stay safe and yeah, be happy. Because I see that all of you are boring in class. Maybe one of you can like have intrigger your friend to be like having fun in class next time. Okay. Okay, bye-bye.
Thanks, Doctor.
Thank you, Doctor.
Thank you, doctor.
Thank you.
Okay, bye.
Thank you,
Thank
Doctor.
you. Thank you, Doctor.
Thank you, Doctor.
Okay, bye-bye.
Doctor, are you still here?
Yeah.
I am not in the WhatsApp group yet. I already text you.
Okay. What happened? You cannot enter the WhatsApp or what?
No, this is my first time in your section. I moved
Oh, okay.
from the section.
Then how come you can enter and join our class?
I asked a friend of mine. He sent me the link.
Okay, maybe you can log in into your e-learning, because I already share the link over there. But after this also I will check your PM. Then I will like share the link also.
Okay. Thank you so much.
Okay.
Doctor, can I ask about the book? I live in UAE currently, so can I get a hard copy or I just buy the ebook?
For international student, we recommend you to just buy the ebook.
Okay, should I register on the same table?
There is a tab below that you need to
Yeah.
pick whether it is hard copy or soft copy.
Okay, and just type my info there and that's and wait.
Yeah, wait for instruction how you going to pay.
Okay, how much does it cost? Can I ask?
It is 3 USD, isn't it? I forgot already. But in MYR is RM 15.
15. Oh, okay.
But USD, I guess is free.
Okay. Thank you.
Okay.
Doctor, is there any way to pay using credit cards? Because we don't have PayPal here, like in Bangladesh.
I will ask the person in charge for the international payment, because normally there will be only one payment link, and throughout maybe there is also experience from your senior having that problem, so the person in charge will handle it. Okay.
Okay.
How to pay later on I will like share in our group. But first, you
Okay.
need to like fill in your information whether you want to buy or not.
Okay. Thank you.
Okay. Thank you.
Thank you. Have a great
See
day.
you soon, Doctor. Thank you so
Okay.
much.
See you next week. Bye bye.
Bye.